Hey there, everyone. Welcome to XSTEM All Access. I'm Maynard Okereke, also known as the Hip Hop MD, and I'm excited to be part of this series showcasing some of the coolest minds in STEM. In this series, we'll dive deep into the diverse world of STEM careers and the individuals leading the way in science, technology, engineering, and math. As your guest host for this episode, I'm excited to chat with Captain Adrian Castillo. He is the Starfire Optical Range Research Section Chief for the U.S. Air Force. I'm going to ask him all the questions you'd like to know about his job, like what inspires him and what it's like to use innovative technology to track objects in space. Make sure you subscribe in the YouTube description below and follow us on social media to get updates on new XSTEM episodes. Check out the full library of episodes available on demand right here. You'll find topics ranging from aerospace engineering to meteorology, computer science to chemistry, and everything in between. Plus, educators can access NGSS and CASTLE-aligned lesson plans to accompany each and every episode, including today's. These lesson plans are written by educators for educators. With your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest, #XSTEM, and tag me at Hip Hop Science Show. Before we begin though, please join me in thanking our partners, the U.S. Air Force and the U.S. Space Force, for making this XSTEM series possible. Now, before we begin, let me tell y'all a little bit about myself, because I'm sure y'all probably wondering. I am a science communicator with a background in civil and environmental engineering. I started my platform, Hip Hop Science, to help spark curiosity and excitement in STEM by using music, entertainment, and comedy as tools to educate on a wide variety of subjects. I think curiosity is key to unlocking so many amazing things in life, and I'm always excited to share fascinating things happening in the world of science, which is why I'm so hyped about our interview today, and I hope all of you are just as excited. Now, it's time to hear from today's speaker, Captain Adrian Castillo. In his role at the United States Air Force, Captain Castillo is responsible for managing the development of emerging space domain awareness technologies. He supervises personnel at the Starfire Optical Range, pushing the boundaries of adaptive optics research to provide tracking of objects in space. Captain Castillo, welcome and thank you for joining us today.
Thank you, Maynard. I'm excited to be here.
I know the audience is excited to hear from you, so let's jump right into our first question, all right? In your role, you are responsible for managing the development of emerging space domain awareness technologies within the Air Force Research Laboratory. Can you tell us what types of technologies these are and why are they so important?
As you already stated, I work for a place called Starfire Optical Range. This is Starfire Optical Range. It's a set of telescopes out in New Mexico where we do some specialized astronomical viewing and space domain awareness, which I will talk about a little later. So in particular, Starfire Optical Range develops and improves systems and processes dealing with something that we call adaptive optics. Adaptive optics can be a bit tricky to understand, but let me try with a analogy. So I'm sure some of you know what noise-canceling headphones are, right? So noise-canceling headphones, you put them on your ears and you hear a little less from whatever noise is going on outside. So what's going on is you have little microphones that are on each side of the headphones. They catch the external noise, and what they do is they go through a little processor. Inside that processor, it does something we call inversion. So it makes the opposite of that signal, and then it plays that along with whatever music you are listening to. So how does that apply with light? Well, you can imagine whereas noise, when it comes to sound, is easier to understand, right? Maybe a truck is driving by you, or you got some flowing water, something like that. In the case of light, it's a little different. So I want you to imagine for a second, you're underwater, you're looking up from, let's just say, a pool, looking at the sun from under the surface. Well, the sun that you know looks like a perfect circle, instead, looks like this twinkling mass of light. You can imagine that this actually is the same thing that happens at the top of the atmosphere. And in reality, the little pictures you'll see in the bottom right that I'm showing are pictures of stars through the atmosphere. So when you zoom in a lot, you get actually the same exact effect that you do on the surface of water. All right, so the problem is the same, but the solution is not necessarily the same. It's the same concept, though. So instead of using a microphone to pick things up, we have to do something a little different. We have something called a wavefront sensor, which is a camera. So you can imagine this is a mirror that actually can change shape based on whatever we need. So since we know what this reference star, or I will say guide star, is supposed to look like, we can go ahead and change that deformable mirror or the wavefront corrector until you get to the point where you have corrected the star. So you've done the same thing as the noise canceling headphones does, where you remove that noise. And then you go ahead and keep applying these corrections thousands of times per second. So that's the basics. But what's so special about what we do here at Starfire? Well, the normal correction that we do, the normal guide star that you would use, is actually a natural star. But over at Starfire, because of the types of things that we track in the night sky, we don't look just at stars. We look at satellites. And satellites move real quick, very fast across the night sky. So I can't just pick out a star up there and say, hey, I'm going to look at this thing, and so this bright star is nearby, and I can use that as my reference. No. Instead, we have to create our own star. So we have different types of what we call laser beacons, where we basically excite pieces of the atmosphere so that they shine like stars do. And in doing so, we create our own reference stars from laser light. So actually what you're seeing in the picture I'm showing right now is exactly what you would see on the ground. So when I'm standing nearby, I can look up at the sky and see those lasers lancing into the sky. It's pretty cool. Now from there, you'd be very surprised at what adaptive optics can do. I'll show two examples, one being astronomical and one kind of being closer to space domain awareness. So here you'll go ahead and see a planet, Neptune in particular, I believe. You'll see no adaptive optics and adaptive optics. Basically, it removes a lot of that atmospheric blurring. And it does the same thing if I were to go ahead and look at a satellite. So let me show you that next. There we go. So where you would have a lot of blurring of different types, adaptive optics can go ahead and take away that interference and make the image very clear. It's a little bit of an odd process, but it is really cool to be able to see that kind of thing happen in real time. And that is the basics of what we do at Starfire.
Amazing. I absolutely love it. And you know, as a headphone guy, that analogy personally hit home. So, adaptive optics allows you to use ground telescopes to see things like satellites in space clearly. This must keep your day-to-day job really interesting, working with such innovative technologies. Could you take us through a typical day?
So, well, nowadays I tend to work more with people and personnel pieces of Starfire as the research section chief. Back when I was still working on the table science, it's really hard to pin down what a typical day is. Really, there is no typical day. Science doesn't always follow a routine. For one experiment, maybe you get into a routine for a week or two, but then when that one's done, it's time to move on. Of course, that's for shorter experiments. Longer experiments can take a very long time, like, say, the LIGO experiment where they were trying to find gravitational waves. But for me in particular, some days I would spend hours in the labs, whether this is building antenna to measure electromagnetic waves, or it was to go ahead and image things with camera in the lab to go ahead and get some references. Sometimes I would be on the computer instead, doing a lot of programming, coding of all kinds, modeling and simulation being one of my specialties. And other times I would be going ahead and coding optical equations. Go instead of a visual check, checking just mathematics. Let's make sure that what I think is true fits the mathematics. And even other days, research papers, right? So no matter where you go, you need to be able to keep up with the cutting edge of science. And not only that, your specialty in school isn't something you're always going to remember by the time you get on the job. So for me in particular, I know I was a physicist, but that's generalized, right? When I moved to NASIC, National Air and Space Intelligence Center, I needed to learn about infrared technologies, camera systems, and satellite to ground imagery. When I moved to Starfire, I needed to do the opposite. I needed to learn ground to space imagery. So you always need to be learning more and willing to learn more most of the time whenever you have a chance. And other times, working with telescopes, of course, we have to work at night. So days versus nights, one job versus another. Every experiment, every tasking is slightly different. So typical days are a little hard to nail down there.
I'm all about finding ways to challenge myself and make sure I'm continuously learning. So that's awesome that you found a career that promotes that. I love it. And I know all too well that not having a typical day definitely keeps things new and exciting, and that part is very, very, very dear to me. And speaking of learning, you earned your bachelor's degree in space physics. Now, this isn't a degree you hear about every day, obviously. Can you tell us about this course of study and what inspired you to pursue it?
So space physics is an odd degree. I would call it mostly a supercharged general physics course. We did everything many of my colleagues did in their undergraduate degrees, but Embry-Riddle had a much higher focus on lab work and an elective study. We took a lot more courses in general and were given the option to capstone with a research project. Um, so funny enough, and actually I'll go ahead and throw a slide up for now. When I was getting ready to get ready for college, I was in high school still. I was planning to be a music major. I was walking through Barnes and Noble, and you'll see a picture of a book by Michio Kaku over there called Hyperspace. On my way to the science fiction section, I happened to knock down that book and picked it up, flipped through some pages, and the rest is history. There I was in college a few years later. You'll see to the left an optical bench with a helium neon laser. It was one of my experiments. We were doing some laser resonance cavities. So it doesn't take much sometimes to change your future, but especially for me, I think everything was for the better, and I very much enjoy what I do now.
Okay, okay, hold up. You're in Barnes and Nobles and accidentally knock over a book by world-renowned physicist Dr. Michio Kaku, and that completely changed your trajectory from a music major to space physics? That right there is a story in itself. I know for me, music was a big passion of mine, and I learned so much from having a musical mindset. I often use songs to memorize things or find myself going down the wormhole of research after listening to some song lyrics. It was really that connection that made me understand music and knowledge and really sparked my idea for this whole hip hop science platform. So, for everyone out there listening, this just goes to show that inspiration can truly come from anywhere. Okay, Captain Castillo, let's shift flight paths a bit and talk a little more about the space objects you track, because that sounds like real life science fiction. Exactly what objects are being tracked and how do they impact the general public?
So we track all kinds of things in all kinds of orbits, right? From LEO, low Earth orbit, all the way up to geosynchronous Earth orbit. The primary benefit of our adaptive technology is we can go ahead and image some of these things even with our relatively small telescopes. We are able to directly image different kinds of satellites, rocket bodies, space stations. I even got to see the Hubble Space Telescope once through our telescopes. Anything that's large enough physically for our telescopes to image, because telescopes are indeed limited by physics. You can only go so small based on the size of your aperture. But we have techniques that allow us to see even smaller satellites in certain specialized cases. So as for how it affects the general public, Well, let me show you a quick picture here. So what you're seeing on the screen right now is a simulation. So this isn't even the real thing. It is a simulation of space debris or space objects currently in orbit. And even in this simulation, it looks like a lot. And even though, space at the end of the day is bigger than you think it is, it can get crowded up there. And when not only the military, but when the industry wants to put things up into space, it's important that we know where things are. It's that awareness of the space domain. This isn't only industry, obviously, where it is very important, say with Elon Musk putting up all his Starlink satellites or any of your cell phone connection satellites, cable satellites, all those things already up there. But then you also have to deal with the military space where you have different countries going ahead and putting up there's different types of surveillance satellites and all kinds of things. The space domain is getting full, uh, and we have to know what's up there in order to be aware of the battle space.
Well, it's good to know that someone is helping keep space organized. I think it's easy to forget just how much stuff we actually have orbiting around us in outer space. Most people may not realize the essential role that satellites play in our daily lives, and your work really helps prevent these important objects from running into each other so we can all go about our day to day business. So, thank you very much for that, Captain. Okay, now, along with protecting our space objects, I see you're also the recipient of some prestigious honors, including the Air and Space Achievement Medal and the National Defense Service Medal. Tell us a little more about these awards and what they mean to you both personally and professionally.
The National Defense Service Medal is one that represents my service to the United States Air Force as a whole. So for me in particular, it's proof that through training and adversity through it, I still managed to make it in. Went through a lot of things balancing education, employment, training, and sports. It gets difficult sometimes, but here I am. Officer in the greatest Air Force in the world and on the bleeding edge of development. There's nothing more I could ask for than, getting that opportunity and having made it this far. Now, the Air and Space Achievement Medal represents the culmination of my duties as an analyst over at the National Air and Space Intelligence Center. It's small, but it reminds me that some of my contributions were in fact important. Let me go ahead. So I don't have a lot of pictures of my time since I'm not allowed to exactly take pictures in many places, but at least I could show you. So on the top right, you'll see one of my commissioning photos, or that's when I took my oath of office to the U.S. Air Force. That was the end of my college career. And on the left, you'll see fires. So one of my specialties when I was working at NASIC was going ahead and observing fires and seeing what kinds of signatures they would give off to different types of cameras. The bigger picture is out in the middle of the desert, creating a fire. And the little picture, which you can't see too well, is actually doing some control burns with the U.S. Forest Service out in California. So I've had my opportunity to do some great things, and sometimes these awards can go ahead and remind you of the contributions you've made, and that can be very important, especially in the longer careers.
Absolutely amazing work, Captain Castillo. Congratulations to you on all of those special recognitions. You mentioned the hard work you put in to get where you are in your career. Following a STEM career path can be challenging. Did you encounter any obstacles or specific challenges in your pursuit of a STEM career? And if so, how did you overcome them?
But for me, when it came to STEM in particular, I had a lot to do when I made my decision after picking up hyperspace. Math was never my greatest subject. Actually, literature was. I was an incredibly good writer, but I needed to fix math up. Um, so I spent some time doing that and eventually did fairly well for myself when it came to mathematics. Enough that I actually got into my school of choice and was able to make it through my program. Um, so it wasn't only that, though. My parents couldn't afford to directly pay for college, so I did have to take out loans, and I had 3 jobs in order to support myself through my degree. I went into ROTC to help that a little bit, but at the same time, I do believe that everyone should serve their community at some point, and my way of doing that was to join the Air Force. After graduation, my talents were always in writing and music and not math, but I still made it through, and I was extremely proud that I managed to do that. There are times, and you'll realize this if you go to college, if you pursue STEM, where you're thinking of maybe giving up. Maybe this isn't for you. And just take some time, right? In the moment things get a little hard. Sometimes you think, well, I'm way better at this. And maybe you are, but what do you want to do? For me, I wanted to be in science. And so I fought through every second of the way. It's never easy though. Adapting and overcoming means not to put everything into one basket, to keep a good support system, to go ahead and make sure that you know what you want, you know what you need to do to get there, and you have a backup plan in case it fails. So, especially for me, I had my friends and I had my hobbies. I kept the things like writing, like music, playing in bands, playing magic, just to help keep me sane while I go ahead and do the hard work on the other side, sometimes banging my head against the wall to figure things out. But with every day, with every balance that you reach, you go into work the next day sane, ready to push on, and proud of the things you can do.
Pushing through those moments when things get challenging can really shape the individuals that we become. And it's really great that you're able to keep your love of music and writing in your life. Hobbies and passions are so important to keep us balanced. I think that's really one of the ways I've been able to stay motivated in doing the work that I do, is that I never really look at it as work. Music and science were two things that I loved since I was a kid, but I spent most of my life trying to separate the two and focusing on being one or the other. I think the ultimate happiness and satisfaction comes when you can find a way to merge all of your passions together and use it to help build a career. That way, your day to day job can truly be what you love doing. Now, speaking of love, I'm curious, do you have a favorite part about your job?
So, funnily enough, a favorite part of my job isn't necessarily the thousands of lines of code or the basis for lasers generated from diamond crystals, and not the big telescopes or the guide stars that we put in the night sky. And that actually, in this place, it has been the people. Um, for every up and down this job has, for each incredible new thing I learn, it means more because it's more than just my job. It's Starfire has become a little family for me. It's a support system, whether technical or personal, right? We're a team. We come together, we make things happen, we cooperate, we coordinate. Uh, Buzzwords abound, but what it really means is when I reach a roadblock, I'm not afraid to reach out to my colleague, or I guess to one of my friends or my boss, and ask a question. And on the flip side, they're not afraid to do the same thing to me. And that's important, right? One of the biggest things people tend to forget in the STEM fields is it's not a solo job. You have to collaborate. You have to build upon the shoulders of giants. You have to go ahead and find the information you need. And sometimes that means working with other people. And so it is a blessing to be able to find a group where you can work together very well and build off of each other's ideas. When you find a true research team, you'll find you can accomplish a lot more than you could ever do alone. So, the favorite part of this particular job is the fact that I have a team that's been galvanized so well.
Collaboration and teamwork are critical to success in most fields, but especially in STEM, where the benefit of different perspectives is key to solving the problems that impact all of us. But I do have to say, if I was working with lasers generated from diamond crystals, that would be pretty on par with teamwork. Just saying. So, Captain, before we close, can you offer some words of advice or words of wisdom to the students watching today?
Oh, words of wisdom, huh? Well, I think the most useful thing I can leave you with is to build resilience, right? Don't lose yourself wholly to any one thing, because if it ever happens to disappear for one reason or the other, it will be devastating. Instead, you have to build a foundation. You have to find friends, find hobbies, find things you're passionate about, because at the end of the day, you need something to look forward to. But I can say for certain that all the things I've done to build a foundation have helped me become a better person and become a better scientist in general. And it all keeps me sane through every twist and turn life can throw at me.
That is amazing advice for all the students watching. Stay resilient. I couldn't have said it better myself. Captain Castillo, thank you so much for joining us today.
Thank you, Maynard. Thank you, everyone, for having me. I hope that at least some of the things I've said have been useful or interesting to you. I hope that you guys do very well coming up. It's always great to see the next generation move to the forefront, move to take their place. So I can only hope that the little things that I was able to provide here can help you move forward. And even if you don't become STEM, right? We all have our challenges. We all have our tribulations to make it through. I hope that at least some of the things I said can apply and help you through. So good luck with everything, and it's great to meet you all.
Thank you for sharing about your wonderful work that truly merges science fiction with real life. I know everyone that's listening right now feels truly inspired. And if you're still feeling hyped about the amazing work that Captain Castillo does, check out this brief video to see some more cool jobs in the U.S. Air Force. Make sure you check out the Air Force and Space Force online and follow them on social media to keep up with all of the amazing things that they're doing. I'd like to thank all of you for tuning in today. Make sure you subscribe to the YouTube channel in the description below and follow us on social media to get updates about new episodes. Trust me, you don't want to miss any of them. Plus, you'll get access to fun weekly content for students and teachers, such as STEM facts for students, classroom tips for teachers, and so much more. And don't forget to check out the full library of episodes available on demand right here. Each one has an NGSS and CASEL-aligned lesson plan for teachers to use in the classroom. With your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest #XSTEM and tag me at Hip Hop Science Show. You can also keep up with me and the work that I'm doing with my platform through my website and social media right here. Everything from educational online videos to how you can collaborate with me for any in-person workshops and STEM outreach projects. I had such a blast being your host today, but don't sign off just yet. You want to stick around through the end of this video for a fun trivia game that you can do in the classroom or at home. Have fun, everyone. Peace.